I'm back. Well, hello guys. This is Michael from Salt Lake City. It's time to start a brand new project today. I've been absent from YouTube for a little while, had some personal things that I've been dealing with that have kind of kept me away from being in front of the camera. But I'm ready to get started again on this on a new project. And actually, this is a project that I started a long time ago, but never got very far because I ran into some snags. Those snags I have since, I believe, resolved, and I can go ahead and move forward with this project. And actually, the timing is really good because I'll treat this as a brand new project. The only thing is I've already disassembled the chassis, as you can see from the cabinet. So I'll have to, kind of, it's a pretty straightforward one. I'll have to show you putting it back together. And as I keep promising, but I haven't yet delivered, I'll have to go ahead and start showing you both the disassembly and assembly on these things so that it's pretty clear what to do with them. Okay, so what is this? What is this radio? As you can probably guess, it's a mid-30s radio. I think this one is 1936, although I'll find out. You can go ahead and take a look yourself if you're interested. It is a Westinghouse model WR-212. And this is a very nice tabletop. I am not going to be doing the cabinet. I'm going to do some minor repairs because the cabinet's coming apart and one of the sides is coming loose. I'm going to be fixing that. There is a separation in the wood at the top of the cabinet here, but it almost looks like it was made that way, although it wasn't. We're going to leave that be. This radio, I'll go over it with some Howard's Restore, and I'll probably show that to you when I get to that point. And I'm going to leave this speaker cloth the way it is. In fact, it's nice and tight, and I don't see any reason to mess with it. That's a nice looking speaker cloth. So we're going to leave this cabinet alone. I'll probably at some point remove this escutcheon for cleaning purposes. Same with this tuning eye escutcheon. Yes, this radio has a tuning eye. It's a 6E5 if I remember right. And so this will be a pretty straightforward project cabinet-wise because I won't be doing much. Let's show you what it looks like inside here. Not much to it. Okay, there's a speaker board, nice sturdy speaker board. There's a gasket here that I believe is supposed to run along above the knob holes. I'll go ahead and put a new one to that in. It just seems to be made of rubber and it's just sort of dried out. I'm not sure what this bracket, I don't remember. I'll have to look at my old photos, but there's a bracket right here that I'll have to check out. I think that probably supports the tuning eye bracket. Other than that, it's got some holes drilled in it for ventilation, and it's a pretty straightforward cabinet, one that I won't have to do much other than clean up. So I'm going to go ahead and set that aside, and I'll show you the radio. Alright, let's take a look at the chassis for this WR-212. Here it is. Now this is obviously the tubes are removed and a bunch of other stuff has been removed. I haven't really done the discovery on it yet, so there's going to be a lot for both of us to learn as we go. As you can see, it looks like as I turn this big disc, tuning condenser turns with it. So, and if you were to look down in here, which we'll explore as we go onto this radio, there is a clockwork mechanism for tuning. So it looks like there's a pulley right here, so it'll be a string-driven tuning. See, I'm operating this little pulley. This clockwork looks to be in really good condition. It looks like it maybe has been over lubricated, but the lubricant hasn't hardened. A lot of these wires that look old will look pretty good when I'm done. There's no need to replace them. These are all cloth insulated wires. They're really not brittle. So that's going to be pretty good. We'll leave those be. Lots of cans. Right, so I believe these are the 2 IF cans, and I have a note on this that the second IF has an open primary winding. I'm going to check that. I'm going to go over that again and check it again just to be sure. I do have the schematic for this radio already. And of course we have some electrolytics here. I may or may not restuff these. It looks like, yeah, they're going to be pretty easy to get out of there. So I may restuff them if they're singles. 6 microfarad, yep. 12 microfarad and 18 and 16 microfarad. So each of these is a single one. which makes it nice. These will be restuffable, and that'll save some space underneath. I don't like restuffing the doubles and triples because it gets really tough to fit everything in there. If you look real close, down in here you can see the drive pulley for the tuning. I'm turning that right now. So it's right down in here. And as I mentioned a few minutes ago, right up in here is the driven pulley for this tuning. See, when that pulley is turned, it operates the whole tuning. I'm going to call this the tuning drum for lack of a better expression for it. So this whole device here, I'm going to call the tuning drum. Okay, it is a 3-gang tuner, tuning condenser. So it'll have an RF section, an amplified RF section, tunable RF. So it's going to be a pretty nice set when it's all done. We'll go over what all these switches are as we proceed. I just want to get an idea of the general condition of the radio. So we're going to kind of take a little aerial tour of the thing. You can see there's a lot of corrosion right now on the chassis. Now, there's a lot of corrosion on this chassis. I am probably going to clean that up and probably spray it, because you see this tuner section of chassis looks removable a la Philco. So I'm going to go ahead and yank that out, and I'll rebuild that section separately. While I do that, I'll go ahead and pull the tuning condenser off of that sub chassis so I can work on this chassis, clean it up, and I'll probably paint it gray, and then I'll clean this all up and paint it gray as well. Patina is one thing, nasty corrosion all over a set is another, and this needs to be taken care of. So I will probably not do much with the tuning drum, except maybe I'll paint it. If I do, I'll probably brush paint it, because there's too much there that I don't want to get paint on. So there we go with the top side of this radio. Let's take a look at the underside. Okay, there we go with the underside of this radio. It's a bit cleaner underneath than it is on the top. But as you can see, there's still some corrosion here. I won't probably do much with underneath. Some of that looks like it might actually be rosin. So, that's no big deal. This tuner section I'll be real careful with. I've done some RCAs that are set up a lot like this. And this may even be an RCA radio. At the time, RCA was building a lot of Westinghouse stuff. So I'll pull this sub chassis off of here, and I won't really mess with these coils much, but I will replace the paper capacitors that are down in there, paper and wax capacitors. There'll be a couple of them in there. There always are. There's another one down there. So I'll get to those. And that'll make this stuff here a lot easier. It looks like there was another electrolytic right here that may or may not be a replacement. Some paper and wax. These all look really easy to get to, so this won't be a terribly difficult chassis, I don't think. Lots of capacitors here. There's going to be underneath this terminal strip, there will probably be a couple of caps and a big power resistor in there. But it shouldn't be any difficult thing. Yeah, these caps here, these electrolytics, will probably be fairly easy to restuff. I'm not a big fan of restuffing. Personally, I think it's historically better to not restuff than to restuff, but I don't want to drill a bunch of holes in this chassis either if I don't need to, and this might just work out really well. All right, that's a first look at this Westinghouse WR-212. We're going to get real cozy with this radio, because this is going to be a rather in-depth series. I think I'm probably going to be at this one for a good 10 or 12 parts. So we'll get started on it. First things first, I'm going to start taking things off that can come off easily, and that's probably going to be that tuning drum up top. All right, guys. As you can see, I've got a schematic hanging up. I'm ready to start working. And their chassis is ready for me to start doing what I need to do. First thing I'm going to do is I'm going to check out the IF coils, because I had one that I thought was open, if I remember right. And it might have been an oscillator coil. I'll have to take a look. I've had some people ask me about about schematics, you know, suggest that, hey, you know, maybe I show the whole schematic at some point in the video, just a real quick view in case someone wants to go back and take a look at it. So there you go. It's pretty hard to get this one all in one frame. It's a pretty big drawing, but in Westinghouse drawings, if you've never worked on a Westinghouse, and some of the RCA ones were better, this drawing looks like a Westinghouse drawing to me. They're not all that easy to read. There's a lot of handwritten stuff on there, but let me do a real quick aerial sort of 5,000 foot view real quick in case we need to review it later. In case you want to check some of my work, you might need to. So there we go. It's got a 6K7 IF, 6H6 as the second detector, and this is the glass type of that tube too, so that'd be pretty interesting. 6F5 as the first audio frequency amplifier, and the 6F6 as the power amplifier. Power supply sits down here with a 5Y3 rectifier. The IF frequency, as you can see, is 465 kilocycles. And there's some voltage measurements there I'll need later when I get the radio closer to done. It looks like these are the various sections of the band switch. So there's a front section. Okay, I see. Front section, rear section. All right, so trying real hard to see this while looking at the camera, not so easy. So anyway, we have the, it looks like the oscillator coil's there, right there. Antenna coil set right there, showing the band switch connections also. All right, take a look at the can on the left there. See my note on the top of it? Open primary winding. That's the first IF transformer, and it looks like when I measured this before, I found a problem in this can. So that usually means a broken wire that you measure infinity on your meter. So let's take a look at it and see if we can figure out why. All right, folks, let me go ahead and pull this cover off. I've already loosened it. And you're going to see this first time right along with me. So let's hope it isn't too bad, too scary. This radio, it does look pretty scary in a lot of ways, so I don't know what I'm going to see here. All right, there's the cover. Pull this grid cap out of the way here. Oh, that's not good. Right away, what do I see? What a busted wire. I'm sure that is a wire for the primary, and it goes right to this terminal right here. The other side of the primary is this terminal right over here. So I see the reason why I got open for this primary on this transformer. I already measured, you know, from here to here, which is the secondary. So let's get on this and see what we come up with. I'm going to have to repair that. So, you know, these little skinny wires are a real bugger to repair. So, but I've done it before. So we'll go ahead and do that before we do much else. This IF transformer's got to work. Might as well get it taken care of. Okay guys, the thing to remember here when you're working on these IF transformers is that everything is really fine and really fragile. So you want to take your time, take it easy, don't rush it, and don't try to manhandle things. Alright, so the first thing I want to do is I want to get that little terminal right there clean. There's a big glob of ugly solder on that. Don't know if that's factory or not. There's enough ugly soldering in this radio that I'm beginning to suspect that factory made ugly soldering. But who knows? So do my usual method of solder removal. I know other people like to use solder suckers. I'm not a big fan of those. So we'll just get that good and soupy and melt it off of there. You've all seen this before. I want this especially clean, so I don't care if I use a little extra solder wick on it. I want it clean. And then I need to remove the old bit of wire so it's not in the way. Actually, I might use that old bit of wire and solder the two ends back together and see if that works. So the next thing is to try and clean this bit of wire. Let's see if I can get there. You don't want to pull it so hard that you break the other end. See, that's the trick. Alright, so now I'm going to clean that with a little bit of lacquer thinner and see if that does anything for me. This is tricky, guys. This is one of the trickier things that I do, and I'm sure there's better ways. If you know of one, please let me know. But I want to get this wire as clean as I can because this wire is hard to solder to anyway, and then dirt just makes it harder. So we're not seeing very much with the little camera, but that's okay. Okay, so just take your time, get it as clean as you can. Alright, so you want to make it so that you can solder these two bits together. I suppose I could just connect directly to the terminal. There's enough wire there to do that, but if I screw up, then I'm going to run short. This way I can take these two pieces right here, twist them together, and solder them together. Let me see if I can make that work. I'm going to need a little bit of rosin. Not too much, I don't want to make a mess. I might just try to solder that directly to that terminal after all. Let's see. This is a tough one, guys, because you pull on the wire too much and then you can't, you break it. It's very risky. Sometimes you have to cut the wire back and solder on a real fine piece of wire, but I'm hoping not to have to do that this time. Now, the trick with this is to get a good glob of solder on your iron so that you can put a lot of heat to it right away and the solder will flow and stick. Let's see. This wire will not want to take solder. That's how it always is. It looks really messy, but it's effective. Alright. Now that looks horrible, and I would otherwise not be proud of that, but this wire is nearly impossible to solder to. If you can get it to stick, that's all you need. So, now, let's test it out here. see what we get for DC resistance across it now. Clamp that on there. Here we go, 56.6 ohms, which is roughly the same as the primary on the second IF transformer. So I think this is probably good. Now, normally on a part like this that's as dirty as this is, I would clean it. But the truth of the matter is this thing is good now, and the more I leave it alone, the better off I'm going to be. So I'm going to leave this thing alone, put the cover back on it, and move on. Let me clean up this cap, and the wire insulation is good. I'm going to leave that alone. Alright, I'm going to clean the cap while the cover is off because I have more room to work. But I don't have to do it that way. The idea here is just get the corrosion off. Not worried about the chassis because I'm going to be doing the same thing to the chassis soon. Okay, that'll work. I'll probably coat this insulation with some lacquer later, but I may not. We'll see. You feed that grid cap through there. Drop the cover down onto the chassis. Okay, see that? Feed the grid cap through the hole here. Drop the cover onto the chassis. These little clips here, they're expandable clips. I don't know if you can see that, but they expand, you see, that they grab. There's some Philcos made that way too. Other radios as well. I've seen GEs like that. You push them in like that. There we go. Okay. And this will fit down on the 6A8 like so. Actually, I think it goes on the 6K7, but anyway. Now, last thing, we measure it from the other side just to be sure. Take the meter and just measure across the secondary. Let's see what we get. There we go. Oops. There we go, 57.0. That's about right. Okay. So we're in good shape on that. We've repaired that first IF transformer. And the best thing we can do now is leave that bugger alone. And if the other transformer is good, which I believe it is, because I don't have any notes on it, then I'm going to leave that one alone too. I don't like to mess with IF transformers or any coils with that fine wire because it's easy to mess those up. Alright, let's move on. To measure the resistance once more on these IF transformers, you check them from the bottom side and you identify which wires are going to what. So here's a wire coming from the other IF transformer over to this one. Well, if you look at the schematic, there's only one wire that does that, and that's highlighted in pink there on part of it anyway. And that goes from the bottom of the primary of the first IF transformer to the bottom of the primary of the second. Okay, so now I've identified one wire that leads to the primary of the second IF. The other wire that leads to that primary is coming from pin 3 of the 6K7 tube. So let's look for that. So there is the 6K7 tube right there. Pin 1, 2, 3 is this little grayish yellow wire here, and it goes right to this terminal right there, and that's where I have the alligator clip. So if I measure from here to there where the alligator clip is, I should get a measurement about 60 ohms. And what do I get? 62.2. So then I know that the primary of the second IF transformer is good. The secondary has one wire going to pin, looks like pin 3 of the 6H6 tube. And the other wire is internal to the can, and it goes to a resistor, 50,000 ohms, and then comes out. So I should get, well, that's going to be hard to measure, but I should be able to measure continuity anyway. It'll be around 50,000 ohms. Should be 50,009 ohms, but let's see what I get here. So one of them is going to pin 3 of the 6H6. So I can connect directly, if I want to pin 3 of the 6H6. 1, 2, 3. And that sure does make that easy. Okay, I don't know if you saw me clip that. That's okay if you didn't. Suffice it to say that I found pin 3 of that 6H6 buried down there. Sorry for the poor camera work. And the other side, I'm going to measure to, I was going to come out of there, it should be about 50,000 ohms or so out of one of these. Sometimes you don't know which one is which. And so you just start taking measurements till you get something that makes sense. All right, so if I measure from pin 3 of the 6H6, and then I come over here, and it's hard to see, but there is a terminal on this IF transformer can right here. It gives me a measurement of 53.8 K, which is about the 50,000 ohms I am looking for, right there next to the resistor number 52. Okay, so that makes sense. So it looks like I have good continuity across both sides of the second IF transformer. All right, guys, I think that's about all I have time for today. But here, take a look at this picture. This is a nicely restored WR-212. It's a real pretty radio, real simple. I like the understated design, and I like the colors in the dial. This radio will have the same colors, real pretty. Next time I get into this radio, the next video, we're going to look into removing that tuner chassis from the main chassis. So that's quite a job. We're going to do that, and then we'll carry on with some other work, and we'll start the actual recap and re-resistor. As always, I won't show tons of details on the recap part because we've all done that, and we've all seen it, and there's only so many times you can watch it before you get so bored you start looking for, puppy dog videos to watch instead. So I'll go ahead and close up for now. And one last thing, take a look at this ad as I give you my closing. From Salt Lake City, your Western Outpost, this is Michael on a Sunday night, May the 7th, 2017. And that's all for now.